Hello, everyone. Tonight, as you settle into comfort, we're going to journey somewhere unexpected, somewhere small, somewhere hidden, somewhere extraordinary. To the world of builders, tiny builders who create structures that dwarf their own size, structures that reach toward the sky, that regulate temperature, that breathe. The termites. These small insects, often misunderstood, often feared, but carrying within them architectural knowledge that would astound any human engineer. They don't just build shelters. They create cities, cathedrals, climate-controlled palaces, rising from the earth, towering over the landscape, lasting for decades, sometimes centuries. How do they do this? How do creatures with brains smaller than a grain of sand, with no blueprints, no leaders, no plans, create structures of such complexity, such precision, such beauty? Tonight, we'll drift through their secrets, one by one, gently exploring each architectural superpower, each building, technique, each engineering marvel. There's no rush. Let yourself sink deeper, and together we'll discover how termites became the master architects of the insect world. Let's begin our journey into their towering world. The first marvel is the structure itself, the Termite Mound. But calling it just a mound is like calling a cathedral just a building. These are architectural masterpieces, some reaching 30 feet tall, taller than a two-story house, built by creatures that are each less than half an inch long. Imagine that. Imagine building something 600 times your own height. For a human, that would be like constructing a building over 3,000 feet tall, taller than any skyscraper that exists. And termites do this, not with cranes, not with machinery, not with any tools at all. Just their bodies, their instincts, and time. The mound isn't solid. It's intricate, complex, a maze of chambers and tunnels. There are nurseries for the young, chambers for the queen, storage rooms for food, highways for traffic, ventilation shafts, even gardens for growing fungus. All connected, all purposeful, all perfectly designed. The walls are made from soil, saliva, and feces mixed together into a cement-like material. It hardens in the sun, becomes strong, weather-resistant, durable. Some mounds last for 100 years or more, standing through storms, through droughts, through everything. And the thickness of the walls varies. Thinner near the top where they need to breathe, thicker near the bottom for strength. The shape is aerodynamic, designed to withstand wind, to shed rain, to maximize efficiency. Every aspect, every curve, every tunnel serves a purpose. Nothing is random. Nothing is wasted. The story begins millions of years ago in the forests and savannas. Termites evolved from cockroach-like ancestors, social insects learning to live together. At first, they probably just dug simple burrows, hiding underground, staying safe. But as colonies grew, larger, as populations increased, they needed more space, more organization, better protection, climate control. The termites who built slightly better shelters, who dug more organized tunnels, their colonies thrived, grew larger, produced more offspring. Generation after generation, the building behavior became more sophisticated. Genetic mutations that improved construction ability were passed on, spread through populations, and the behavior became instinctive, encoded in their genes, refined by millions of years. Different species evolved different architectural styles, adapted to different environments. Desert termites built thick walls for insulation. Forest termites built to manage humidity. Each population shaped by its challenges, by its climate, by its needs. until we arrived at what we see today. These incredible structures rising from the earth, built not by intelligence as we understand it, but by collective instinct, by evolutionary wisdom, by millions of years of trial and error written into their very being. We humans, we're proud of our architecture, our skyscrapers, our bridges, our monuments, and they are impressive, truly. But we build with knowledge, with education, with tools and technology. We have engineers, architects, blueprints, calculations, cranes, and concrete. We stand on the shoulders of thousands of years of accumulated human knowledge. Termites have none of this. No individual termite knows how to build a mound. No single termite has the plan. Yet somehow, collectively, they create structures more proportionally impressive than anything we've built. And they do it with materials they find, with their own bodies, following only instinct. A human engineer looking at a termite mound, studying its ventilation, its structural integrity, often comes away humbled, impressed, even inspired. Some modern architects now study termite mounds to learn principles of natural cooling, of sustainable design. We're learning from them, these tiny insects who've been master builders far longer than we have. Picture a savanna in Africa, the dry season, sun blazing overhead. A termite mound rises from the earth, 20 feet tall, imposing, ancient. Its surface is rough, textured, painted in earth tones, reds and browns and greys. Inside, millions of termites are working, constantly, tirelessly. A young worker termite named Ember emerges from a tunnel, carrying a tiny ball of mud. She's been mixing it in her mouth, combining soil with saliva, creating her building material. She moves to a section of wall that's being extended, adds her tiny contribution, presses it into place, shapes it slightly, then returns for more. She doesn't know the overall design, doesn't see the big picture. She just follows simple rules, chemical signals, pheromone trails left by other workers. If a wall needs building, the chemical signature tells her she builds. Thousands of other workers doing the same, each adding their tiny piece. And somehow, impossibly, the structure grows, takes shape, becomes organized. No foreman, no architect, no plan, just emergence. The whole greater than the sum of its parts. By evening, that section of wall has grown by several inches. Smooth, solid, perfectly integrated with the existing structure. All from millions of tiny contributions, each one seemingly random, but collectively purposeful. That's the marvel. Not just the structure, but how it's built. Without leadership, without knowledge, through pure collective instinct. There's something profound about this, about the termites' way of building. It challenges our assumptions about what intelligence is, what knowledge means. We think building requires planning, requires understanding, requires thought. But termites show us another way, a distributed intelligence, an emergent wisdom. No single termite is intelligent, but the colony is. No individual understands architecture, but the collective creates it. It reminds us that complex order can emerge from simple rules, from local interactions, that you don't need a master plan to create something magnificent. Maybe there's a lesson here about trust, about letting go of control, about how sometimes the best results come not from top-down direction, but from many small contributions, each following simple principles, each doing their part. The whole emerging naturally, organically, beautifully, without anyone needing to see the complete picture. Just everyone doing what feels right, what the moment calls for. Now, let's talk about something even more remarkable. The climate control system. These mounds, they're not just structures, they're sophisticated environmental control systems. Inside a termite mound, the temperature stays remarkably constant, around 30 degrees Celsius, 86 Fahrenheit, almost exactly. Outside, temperatures might swing from 40 degrees during the day to 0 degrees at night. But inside, steady, stable, perfect. This matters because termites aren't just living in these mounds. They're farming, growing fungus gardens that require precise temperature and humidity. If it gets too hot, the fungus dies. If too cold, it stops growing. The termites need it just right, and they achieve it through architecture. The mound is designed as a giant lung, a breathing structure. At the base, there are thick walls, chambers where the termites live and work. This generates heat. Millions of bodies, fungus decomposing, constant activity. Hot air rises, basic physics, moving up through the mound. Near the top, there are thin-walled chambers, porous with tiny holes. Hot, stale air escapes slowly through these chambers. And as it does, it creates negative pressure, drawing fresh, cool air from the bottom. Fresh air enters through channels at the base, flows through the lower chambers, gets warmed, rises again. A constant circulation, a passive air conditioning system. No energy required beyond the heat the colony generates, and they adjust it constantly, subtly. If it's getting too warm, workers open more vents at the top, create more airflow. If too cool, they seal some passages, reduce circulation, retain more heat. They're monitoring, responding, adjusting, always collectively. This ventilation system evolved over millions of years, refined by necessity. Early termite colonies probably overheated or couldn't regulate temperature well. Those colonies struggled. Their fungus gardens failed. They produced fewer offspring. But colonies that happened to build in ways that improved airflow, that created better ventilation, they thrived. Their architectural behaviors were passed on, spread. Natural selection favoring better builders, better engineers, better climate control. Different termite species evolved different solutions, different architectural approaches. Some build tall chimneys, some build multiple towers, some create underground cathedral chambers. Each solution perfectly adapted to its environment, its climate, its needs. In humid rainforests, termites build to manage moisture, to prevent mold. In deserts, they build to retain water, to moderate extreme temperature swings. The architecture responds always to the challenges of the environment, not through conscious design, but through evolutionary refinement, through countless generations of colonies that built slightly better, surviving more often, until the architecture became perfect for its purpose. We humans, we've only recently figured out passive cooling, green architecture, sustainable design, buildings that breathe. We use computer models, physics calculations, engineering expertise. And still, our best passive cooling systems are inspired by termites. The Eastgate Center in Zimbabwe, a famous building, its ventilation system was designed by studying termite mounds. It uses 90% less energy for cooling than conventional buildings, because the architect learned from termites, from millions of years of evolutionary engineering. We need technology to understand what termites do instinctively. We need sensors, thermometers, airflow monitors. Termites just feel it, sense it, respond to it naturally. They maintain temperature within 1 or 2 degrees, constantly without any instruments. Just sensitivity, collective awareness, architectural wisdom. We're still learning from them, still catching up to knowledge they've held for 50 million years. Imagine a mound on a hot afternoon. external temperature reaching 38 degrees Celsius. The sun beats down on the structure, relentless, intense. Inside, in the central chambers, it's exactly 30 degrees. Comfortable, stable. A worker named Ash is in one of the upper ventilation chambers. She's checking the walls, sensing the airflow, feeling the temperature. It's getting slightly warm, just a degree or two higher than optimal. She begins to work, gnawing at a sealed passage, opening it slightly. Other workers nearby, sensing the same thing, do the same. Within an hour, dozens of small vents have been opened. Airflow increases. Hot air escapes faster. Cool air is drawn in more quickly. The temperature drops back to 30 degrees. Perfect again. No one told them to do this. No queen gave orders. No plan was made. They just sensed and responded, each doing their small part. And the collective action solved the problem perfectly, efficiently. By evening, as external temperature drops, the vents are sealed again, gradually, carefully, retaining warmth, maintaining stability, keeping everything just right. This happens every day. Constant, tiny adjustments, thousands of them. The mound breathing, responding, alive in its way, all managed by millions of tiny builders, each one limited, but together extraordinary. There's beauty in this kind of intelligence. Intelligence without consciousness, without understanding, without thought. Just pure responsiveness, pure sensitivity, pure collective action. It makes you wonder about intelligence itself, what it really means. We think of intelligence as individual, as residing in one brain, one mind. But maybe intelligence can be distributed, spread across many simple minds, each one doing simple things, but together creating complexity, creating wisdom. The termite colony thinks, not with neurons, but with chemistry, with movement, with behavior. And it solves problems, complex problems, that would challenge our best engineers. Maybe we could learn from this about collaboration, about emergence, about how great things can happen when everyone contributes, when everyone responds, when the collective intelligence is trusted, is allowed to emerge, without needing one leader, one genius, one mind controlling everything. Just many minds, many actions, many small wisdoms combining into something greater. Now let's explore something fascinating, the fungus gardens. Termites don't just build for shelter, they build for agriculture. Many species cultivate fungus, growing it in special chambers, farming it, harvesting it. This fungus, it's their primary food source, their crop, their sustenance, and it's incredibly demanding, requiring precise conditions to grow. Specific temperature, specific humidity, specific air composition. Get it wrong, and the fungus dies, and the colony starves. So the architecture, it's designed around this, around protecting these gardens. The fungus gardens are kept in large chambers, usually near the center of the mound, where temperature is most stable, where humidity can be controlled. The walls of these chambers are specially treated, coated with bacteria that prevent contamination. Ventilation is carefully managed. Not too much air movement, but not stagnant either. And the termites, they're constantly maintaining these gardens, tending them, caring for them. They bring in plant material, wood, leaves, grass, chew it up, mix it with their saliva, their enzymes, creating a substrate, a growing medium. Then they inoculate it with fungus spores, cultivated from the existing gardens. The fungus grows, spreads through the substrate, breaks down the plant material, converting cellulose that termites can't digest on their own into nutrients they can absorb. It's a symbiotic relationship, a partnership millions of years old. The termites provide perfect growing conditions, protect the fungus, spread it. The fungus provides food, breaks down tough plant material, sustains the colony. Neither could thrive without the other. They've evolved together, become interdependent. This farming behavior evolved, probably by accident, millions of years ago. A termite colony storing plant material in its nest, fungus naturally growing on it. The termites eating the fungus, finding it nutritious, easier to digest. Colonies that encouraged this fungus growth, that created better conditions for it. They had more food, more reliable nutrition, grew larger, produced more offspring. Over generations, the behavior became intentional, became sophisticated, became farming. The termites evolved to cultivate specific fungus species, to build chambers perfectly suited to them. The fungus evolved to depend on termites, to grow best in their gardens, to provide optimal nutrition. A co-evolution, each species shaping the other, refining the relationship, until it became what we see today, true agriculture, complete with climate-controlled growing facilities, built by creatures who've never seen a farm, who have no concept of agriculture. Just instinct, just evolution, just millions of years of mutual adaptation. We humans, we invented agriculture about 10,000 years ago. We're proud of this. It changed everything, enabled civilization. But termites, they've been farming for 50 million years, long before humans existed, before primates, before most mammals. Termites were already building climate-controlled agricultural facilities. Our farms are exposed to weather, to pests, to climate variation. We struggle with these challenges constantly, using pesticides, irrigation, technology. Termite farms are perfectly controlled, perfectly protected, perfectly maintained. They don't have crop failures. They don't have contamination issues. Because the architecture, the colony behavior, has been refined for millions of years. Every possible problem already solved through evolutionary trial and error. We're learning from them again about sustainable agriculture, about controlled environment farming, about how to grow food efficiently in enclosed spaces with minimal resources. Vertical farming, controlled environment agriculture. These modern innovations, they're inspired, at least in part, by termites who've been doing it all along. Picture a termite mound cut open in cross-section, revealing its interior. Deep inside, the fungus chambers, large, cathedral-like, humid and warm. The walls covered in the spongy fungus, white and grey, alive and growing. Thousands of termites move through the chambers, tending their crop. A worker named Spore carries a piece of chewed plant material, carefully, precisely. She places it on a bare section of wall where fungus hasn't grown yet, presses it into place, adds a bit of saliva, creating the perfect substrate. Other workers have done the same, covering the walls with fresh growing medium. Within days, fungus will spread across it. Fresh growth, new food. Nearby, other workers harvest mature fungus, eating some, storing some. The cycle continues constantly, endlessly, perfectly balanced. Enough harvest to feed the colony, but not so much that growth is damaged. Enough new substrate added to support expansion, but not so much that it overwhelms. Perfect management, perfect farming, achieved without planning, without knowledge. Just instinct, collective behavior, evolutionary wisdom. A functioning farm, more efficient than most human operations. Built and managed by creatures with brains smaller than the period at the end of this sentence. There's something humbling about this, about termite agriculture. It reminds us that intelligence and knowledge aren't the only paths to success. That evolution, given enough time, can solve problems we struggle with. That instinct, refined over millions of years, can outperform our best designs. We think of farming as uniquely human, as a sign of our advancement. But termites remind us we weren't first, not even close. They've been farming longer than we've existed, and their farms work perfectly, sustainably, indefinitely. Maybe there's wisdom in that, in trusting processes refined by time, in learning from nature, from evolution, from creatures we might overlook. The smallest farmers teaching the biggest ones, if only we pay attention. Finally, let's talk about repair and maintenance. These mounds, they last for decades, sometimes centuries, but they don't stay perfect on their own. They need constant care. Weather damages them. Rain erodes walls. Wind creates cracks. Animals dig holes. Predators attack, trying to break in, creating breaches in the defenses. And the termites, they respond constantly, repairing, maintaining, adapting. When damage occurs, when a wall is breached, the termites know immediately. They sense the change in airflow, the change in humidity, the intrusion of outside air. Workers rush to the damage, hundreds of them, sometimes thousands. They begin repairs immediately, gathering material, mixing cement, rebuilding. Not random repairs, but strategic, purposeful, effective. They assess the damage, seal the most critical breaches first, then work outward, restoring structural integrity, restoring climate control, restoring security. Within hours, sometimes minutes, major damage is addressed. Within days, it's as if nothing happened. The wall rebuilt stronger than before. And they don't just repair, they improve, they adapt. If one area is constantly damaged, they reinforce it, make it thicker, change the design. If ventilation patterns change, if new requirements emerge, they adjust the architecture. The mound evolves constantly, responding to challenges, learning in its way, not through individual learning, but through collective response, collective memory. This maintenance behavior, it's crucial for survival. A mound that couldn't repair itself would fail, would be abandoned. Only colonies with strong repair instincts, with quick response times, survived long-term. Natural selection favored the best maintenance crews, the fastest responders, the most adaptive builders. And the behavior became encoded, became instinctive, became perfect. Now, termites maintain structures that last longer than most human buildings. With no tools, no materials beyond what they find, no knowledge beyond instinct. Just constant vigilance, constant care, constant collective effort. We humans, we struggle with maintenance. Our buildings decay, our infrastructure crumbles. We defer repairs, cut budgets. We know buildings need maintenance. We have the knowledge, the tools, the resources, but still, we let things deteriorate until repairs become massive, expensive, difficult. Termites never defer maintenance, never ignore small problems. They respond immediately, constantly to every issue. Because they're sensitive, because they care, because their survival depends on it. Small problems are fixed before they become large ones. Constant small efforts preventing catastrophic failures. There's wisdom in this approach, wisdom we often ignore. In our lives, our projects, our relationships, we let small cracks grow. We ignore minor damage, thinking we'll deal with it later. And later, the damage is major, the repair difficult, sometimes impossible. Termites teach us, tend to things constantly, respond immediately. Never ignore the small problems, because small problems, if left alone, become big ones. But small problems, addressed quickly, stay small, manageable, fixable. Picture a mound after a storm. Rain has damaged one side, created erosion, cracks in the wall. Dawn breaks. The damage is revealed. Termites emerge, assessing, sensing, understanding. A worker named Clay finds a crack, examines it, begins repair work. She gathers mud, mixes it with saliva, applies it to the crack, smooths it over. Other workers join her, hundreds of them, each working on their section. No coordination needed, no discussion, just everyone seeing what needs doing and doing it. By afternoon, the cracks are sealed, the erosion repaired, the wall restored. By evening, you couldn't tell there was damage. Everything perfect again. The mound maintained, cared for, protected by millions of tiny caretakers who never stop working, never stop caring. Their home is their life. Their life is their home. And they tend it always, with a dedication, a commitment, a consistency we can barely imagine. And the mound stands year after year, decade after decade, because it's never neglected, never ignored, never left to decay, just constantly, lovingly tended by the tiniest architects with the biggest dedication. Let's step back now and see the whole story, the evolutionary journey of termite architecture. It begins around 150 million years ago. Termites diverging from cockroaches, becoming social. At first, simple underground colonies, basic tunnels, rudimentary structures. But as colonies grew, as fungus farming evolved, needs became more complex. Better climate control needed, more space required, better protection necessary. And gradually, over millions of years, the architecture improved. Simple mounds became complex structures. Basic ventilation became sophisticated climate systems. Random building became organized architecture. Maintenance behaviors became refined. Each generation, each species solving the problems of their environment. Desert termites developing thick walls, forest termites managing humidity, savanna termites perfecting ventilation, mountain termites dealing with cold. Every environmental challenge met with architectural solutions, encoded in genes, refined by selection, perfected by time. By 50 million years ago, termite mounds were recognizable as we know them today. Complex, sophisticated, impressive. Rising from the earth in Africa, in Australia, in South America. Wherever conditions were right, termites built and built magnificently. During ice ages, during warm periods, through climate changes, through everything. The architecture adapted, evolved, survived. And now, in the present, termite mounds stand as testaments to what evolution can create, to what instinct can build, to what collective wisdom can achieve. No individual termite knows how to build a mound, but the colony knows, the species knows, evolution knows. And the knowledge is expressed not in books or plans, but in behavior, in genes, in action. Millions of years of architectural wisdom compressed into instinct. And the result? Structures that inspire us, that teach us, that humble us. These tiny insects building better than we can in ways we're still learning from. That's the deep story, the evolutionary story of how termites became master builders. Not through genius, not through intelligence as we define it, but through time, through selection, through millions of generations of refinement, until the impossible became routine and architecture became instinct. So, here we are, at the end of our journey into the world of tiny architects. We've drifted through their secrets, their superpowers of building, the structures themselves, towering, complex, proportionally larger than anything humans have built. The climate control systems, passive cooling, perfect temperature regulation, architectural breathing, the fungus gardens, agriculture older than humanity, climate-controlled farming, sustainable and perfect, the repair and maintenance, constant vigilance, immediate response, endless dedication. And we've seen how it all evolved, slowly over millions of years. Each adaptation a response to challenges, each behavior refined by survival, until termites became what they are, the master architects of the insect world. But here's what strikes me most as we prepare to drift into sleep. The termites don't think of themselves as architects, as engineers, as farmers. They don't know they're impressive, don't understand what they've achieved. To each termite, they're just existing, just doing what feels right, what instinct guides. Following simple rules, responding to simple signals, making small contributions. And somehow, impossibly, magnificently, the complexity emerges. The cathedral rises, the climate stabilizes, the farm produces, the repairs happen. Not through planning, not through understanding, but through collective instinct. Through millions of small actions adding up to something extraordinary. And maybe that's the real lesson, the thing worth carrying into sleep. That great things don't always require great minds, great plans, great leaders. Sometimes they just require many small contributions, simple rules, consistent effort. Each individual doing their part without needing to understand the whole. Trust in the process, trust in the collective, trust in the simple rules. And somehow the complexity takes care of itself. The order emerges, the beauty appears. A termite never sees the completed mound, never understands its brilliance, but it builds anyway, contributes anyway, trusts anyway, and the mound rises. Perfect, beautiful, functional. Maybe we could think about ourselves this way, not needing to understand everything, not needing to control everything, just doing our part, following what feels right, contributing what we can, trusting that our small efforts combined with others' small efforts will create something larger, something meaningful, something beautiful. We don't need to be geniuses. We don't need grand plans. We just need to show up, to contribute, to do our part consistently, dedicatedly, like a termite adding one grain of sand to a wall, one tiny contribution. But it matters. All of it matters. All of it adds up. All of it becomes something. So as you drift off tonight, let that settle in. The image of tiny builders, each one limited, but together unlimited, creating structures that last, that breathe, that function perfectly, not through individual brilliance, but through collective dedication, not through understanding, but through trust, through instinct, through consistency. You don't need to see the whole picture, don't need to understand everything. Just do your part, whatever that is, wherever you are. Add your grain of sand to the wall, tend your section of the garden, repair the small cracks you see, respond when something needs doing, and trust. Trust that all these small actions, yours and everyone else's, are building something. Something larger, something magnificent, something that will stand long after any single contribution is forgotten. That's the wisdom of the termite, the lesson of the tiny architect. Great things are built not by great individuals, but by countless small contributions. By showing up, by doing the work, by trusting the process, by being part of something larger, even when you can't see the whole. Rest now, like a termite at the end of its shift, having done its part, having contributed, having trusted, knowing that the mound will rise, the colony will thrive, the work will continue, not because of any one termite, but because of all of them, together. Let that image drift through your mind, settling, calming, soothing. The towering mound, built grain by grain, tended constantly, lasting forever, by the tiniest builders with the biggest hearts, the truest dedication. You are part of something. You contribute. You matter, even when you can't see it, even when you don't understand it. Your small efforts, they're building something. always. Sleep now, peaceful, trusting, complete, like a termite in its perfect mound, knowing its place, doing its part. Everything is well. Everything is exactly as it should be. Good night.